Okay, guys, so really quickly, I want to talk to you about another important application of the derivative. So I want you to think about if you're driving a car. So let's say, here's a car, and let's say there's this journey, we're getting from point A to point B. We drove 300 miles, and it took us 5 hours. Okay? So there's a rate of change here, right? So at this point, it took us 5 hours. We drove 300 miles. Here we had driven 0 hours, and we're at 0 miles. So on average, how fast was I going? Well, that's a slope question. I know that 300 minus 0 over 5 minus 0 gives me 60. So on average, I was driving 60 miles an hour. But now, does that mean that I was driving 60 miles an hour the whole time? No, your speed fluctuates as you drive, right? So even though on average something's happening, at every second during that time period, your speed was different. So this is where the derivative comes into play. So we talk about average rate of change. That's just when I take the slope. But what is the derivative good for? And this is the derivative. Here's another way of thinking about the derivative, the limit definition. Here I have the slope formula, but we're saying as x and x naught are the same, right? Again, back to this idea, we're on top of the same point. That's your instantaneous rate of change. It's saying at that exact moment in time, at that exact x, the derivative will give me how fast I was going at that moment in time. So that's really the utility and the reason that we care about it so much. So just to do an example, here I have a function, f of t. This gives me the position. So it's telling me at some time, this is where I am. Okay? I'm going to give you the derivative of this really quickly. And you're going to know how I did it really quickly. Okay? So if I want to find the average velocity, excuse me, over a certain interval, well here, I want to know between, let's say time is seconds, so between 1 second and 4 seconds, how fast was I going on average? Well, if I have the position, on average what I can do is say, let's do f of 4 minus f of 1 over 4 minus 1. So that denominator is 3. If I plug everything in, so I have 6 times 4 squared, that's 16 times 6, so that's 96. Minus 16, so that's 80 plus 1, so 81. Minus 6 minus 4, 2 plus 1 is 3. So that's 78 over 3. Okay, this simplifies to 26. So what that means is on average, and let's say this gives me, let's say I'm doing feet and seconds. So it's saying 26 feet per second was how fast I was moving on average, between 1 second and 4 seconds. Since I moved from 3 feet to 81 feet, that was a total of 78 feet, I moved over the course of 3 seconds. On average, I was going 26 feet per second. Same idea here. Let's see between 1 and 2 seconds. I want the average rate of change. So if I plug in my 2, I get 24 minus 8, so 16, so 17, minus 3, gives me 14. So this is saying between 1 and 2 seconds, I moved an average of 14 feet per second. Okay. Now the instantaneous velocity, I'm no longer wondering over an interval. I want to know exactly at a certain time, how fast was I moving? Okay, so 1 second, how fast was I moving at that moment in time? The instantaneous velocity. Well, I have the derivative. That's what the derivative gives me. So if I plug in 1, I get 8. That means at 1 second, I was moving 8 feet per second. Right at that moment in time.